Okay, we're beginning chapter 7 today, and it is called Exponents and Nonlinear Functions, so not lines, okay? 7.1, the first section is about exponent properties involving products, which you just told me is, again, multiplication. So our first example, 4 to the 4th times 4 to the 6th. You see, there is no equal sign. This is an expression. So that's why we see the little funnel underneath it. Sometimes, I just erased it, sometimes we say, we want to simplify this exponential expression. Write it more simply, which means less writing, right? And so sometimes we draw little funnels showing that we're going down and we're bringing things together. Something wider is becoming something narrower, right? That's when you see that, that's what that is about. Okay, we don't add an equal sign to this because it's not an equation. Okay, when we have an equation, we usually have one unknown. Sometimes we have two. We try to solve for the unknowns, but this is just simplify the equation. Let's write this in a simpler exponential form. Okay, so we could talk for a second about what these things stand for. 4 to the 4th. What does that mean? Is that another way to write 4 times 4? No, it's not. That's the number one mistake, isn't it? So what does it mean, Jeremy?
It means 4 times 4 times 4 times 4.
Good. So just that first one, just that first term means I have the factor 4 4 times. 4 times 4 times 4 times 4. And then the second factor we had there was 4 to the 6th. So how many 4s are being multiplied together in 4 to the 6th? Everyone? 6 of them. So if you were going to expand it, and I know you don't want to, but we could do 6 additional 4s. 1, 2, 3, 4, 5, 6. Boom, 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 boom. It's all being multiplied together. So really, when we look at this, how many 4s are being multiplied? There are, I see the answer. The answer is 10. So we could write this all as 4 to the 10th. Okay, so that's what we're going to do today. We're going to take an expression that has 2 exponents that are being multiplied together and bring them together. What did we do with these 2 exponents up here, 4 and 6? How does 4 and 6 become this exponent 10? The operation there is, Sophia? Good, we added them. We basically added exponents, and this expanding here showed us why. Okay? You don't have to expand unless you want to. You just need to write the original as 4 to the 10th. So let's see if you can do it with this one. This one says 9 to the 8th times 9. This is a little trickier because the second term does not show us an exponent. So you have to know how many 9s are in this second term here. How many?
1.
Good. So there's the invisible exponent 1. When you don't see an exponent, there is one factor of 9 there. And in the first term, I have how many factors of 9? 8. So we could write this as 9 to the 8th plus 1. And so the answer is 9 to the 9th power. Okay, good. This says b to the 6th times b to the 9th. b to the 6th times b to the 9th. Thumbs up when you have it. And Ray, what is it? B to the, okay, well we're not wanting to expand it. If we can jump straight to the simplified exponential answer. How many b's would we have in all? B to the, good job, 15. So he added the 6 plus the 9. Okay, here's an interesting one. W to the negative 7 times W to the negative 2. And Tatum? She says w to the negative 9. Thumbs up if you agree. Do you agree? Lots of agreement. That's good because we're just, again, adding those exponents. W to the negative 9. Okay? We're going to find out that there's something more we have to do to that one. But I'll wait a moment before we talk about that. So let's just write this as a rule. It's called the product of powers property. Product is an operation, right? What is the operation, Sabrina? Product. Good. So multiplication of powers. So the powers are values that are with the same base in this case. We have a to the m times a to the n. So what did we just learn we do with the m and the n, Casey?
You add them together.
Good job. So we can write this as what? How would you say it?
A
To the
M.
m. Is that addition?
Oh.
M, I hear it right, plus
Plus
n. But you must have that addition symbol there. Because if you just wrote mn, that would mean multiplying. That's a different thing, okay? We're going to learn that too. So let's go ahead and complete the little sample here. And Bailey? 3 to the second times 3 to the fourth? 3 to the sixth. Excellent. Are there any? Okay, negative exponents. We just saw that in the answer Tatum gave us, the w to the negative 9 one. We're going to talk about what goes on with a negative exponent. So here we have b to the negative 2 times b to the third. Well, that's not hard, is it? We're going to use our same rule we just used, our property of product property here. And I need to hear a new hand. Somebody who has not given an answer, give us the answer to this one. Jimmy. B to the first. Good. Because, again, he's adding the exponents, and he says, look at that. It ends up being a positive exponent. So could you even write this differently, Jimmy? How could I write it differently? Good. We could just say B, right? Boom. Because when you don't see an exponent, it's 1. I have 1 there. I have 1 factor of B that's just sitting there. Okay? Okay, negative exponents. We've got to talk a little bit more about what this means. When we have just a base of A to a negative 2. And I think we have talked a little bit about this year. Thumbs up. Anybody remember? Or hand up. Anybody remember what the negative does? What does a negative do? Good, I see somebody knows. Bella, what does it do? Divide. She says divide. So she's saying it has something to do with like a fraction looking type of thing, and it does. The negative up there has to do with location. It's only location, right? We never multiply the base to the exponent. For instance, if I write 4 to the second, that does not equal what? 8. Good. You understand? We don't go 4 times 2 is 8, do we? What does 4 to the second equal?
16.
16. You're doing 4 times 4. Okay? So if I plug in a negative up there, there's still this 2 that makes us feel like we should do 4 times 4, right? The negative simply says move this entire number to the inverse location. What's the inverse location of 4?
Negative.
Not negative 4. The location, in this case, it's currently in the numerator. It's going to go to the inverse location, so it's 1 over 4 squared. See that? The negative exponent moves it from the numerator to the denominator. We call that the inverse. 4 has an inverse. The inverse of 4 is 1 over 4. 1/4, right? Okay, so using what we just learned there, can you complete this rule here? A to the negative second equals what? Michael?
1 over A squared.
Good job, 1 over A squared. Notice when we moved it to its inverse location, The negative is now gone from the exponent. Do you see that? One of the easiest mistakes people make at first, when they first start doing this, is they move it to the inverse location and they keep a negative with that too. It makes no sense. You haven't changed that. So actually, if you have a negative down in that location, where does that term move? So here it is here. If I have a negative in the denominator's exponent, that term has to now move to the inverse location, right? And where would that be, Jeremy?
Actually, I had a question.
Okay, wait, let me get the answer to this and then I'll take your question. Where would this one move if it's moving to its inverse location? Nico.
It would move to the top.
Good, to the numerator. And so we have b to the nth power. Okay? So if you have a term that is currently, looks like it is not a fraction, that means it's in the numerator, right? Underneath any term, we have what number?
1.
Just like we showed in the example, we have 1. So this term, a to the negative 2, moves to the denominator, and the negative is now gone, right? In the second case, the term with the negative exponent was in the denominator, so we move it to the numerator. Do I need to show you over 1 here? No, we all know that underneath anything is a 1, right? So we leave it as is, okay? One more note here. When you have an answer that looks like, that contains a negative exponent, it is not the final answer. If my answer says, 5 to the negative 2, that is not considered simplified. You must change it to an answer with a positive exponent. So does everyone understand? What would we change 5 to the negative 2 to? Sabrina?
1 over 5.
5 squared. 1 over 5 squared. Good. So now it doesn't have a negative exponent, so it could be left that way. Or you could tell me what 5 squared is. What is 5 squared?
25.
5 times 5, 25. So really the best answer is 1 over 25. Okay, there's no negative exponent and it's most simplified. Okay, so let's try this one. This is something different now. This is 2 to the 4th in parentheses, and then there's a exponent of 2 outside of parentheses. Okay? So this is telling me, what is this 2 out here telling me? That 2 is saying I need to do something. What, Chad?
After you solve the 2/4,
You do it twice, right? So, or there's a second way we can do this. So we could simplify 2 to the 4th and say, what is 2 to the 4th? 2 times 2 times 2 times 2. 16, right? 16 is happening how many times? Twice. Or we could do this. We could say I have 2 to the 4th. How many times? I have it twice based on that exponent, right? And since I have 2 to the 4th twice, we're now back to the product of exponents. See that? And so how many do I have? 2 to the, add those up, and it's 8. Okay, 2 to the 8. So we're writing our answers in exponential form, and 2 to the 4th to the 2nd equals 2 to the 8. So what did you do? What did we do to the exponents to go from an exponent of 4 and 2 to get to an exponent of 8? The exponents were not added, were they? What did we do instead this time? Bella?
Since it was times 2 on the outer side, we did the one in parentheses twice.
Right, and we call that multiplication, right? 4 times 2 is 8. So we're not adding the exponents, we're multiplying them now. Okay? This is called taking a power to a power. Power of a power. I love the names of these rules. Power of a power. Okay? Let's try it with an x to the 6th to the 5th. Okay, so what is x to the 6th to the 5th? Christina?
It's x plus 6, x to the 6 plus 5.
Okay.
So 6 plus 5.
If it was 6 plus 5, we would have this. x to the 6th times x to the 5th, but that's not what we have.